I am your host and I welcome you all into my new video which is about Newton's second law of motion. What is Newton's second law of motion? The Newton's second law of motion is basically related to the three things. First of all, it is force, second there is mass, and third is acceleration. So, in this video we shall talk about Newton's second law of motion and these three things which are related to Newton's second law of motion. So before we go in detail of the Newton's second law of motion, I request you to please subscribe my channel and press the bell icon to get notified about my new videos and about my new updates. So without wasting time, let us go sharply into our new video about Newton's second law of motion. So what is the Newton's second law of motion? The Newton's second law of motion is related to the three things: force, mass, and finally then the acceleration. What does the Newton's second law of motion states? The Newton's second law of motion states that whenever a net force acts on a body, it produces the acceleration in the body. Means whenever a net force will act on the body, it will produces the acceleration in it. If you don't know about the net force, then I will ask you to see my previous video which is about the net force, because you have to know about net force to make your concept clear about the Newton's second law of motion, and it has a very wide concept. So, Newton's second law of motion states that whenever a net force acts on a body, it produces the acceleration in the body, such that this acceleration is in the direction of force. Means, if the force is acting in the direction from left to right, the acceleration will also produce in the direction left to right. Okay. So the Newton's second law of motion states that whenever a net force acts on a body, it produces the acceleration in the body in the direction of net force, such that this acceleration is directly proportional to the force acting on the body. Means the acceleration produced in a body by the force is directly proportional to the force which is acting on the body. Means if the 5 Newton of force is acting on the body, okay, the acceleration will produce, and if we increase the force, we increase the force up to 10 Newton, keeping the mass constant, the acceleration will also be doubled. If the force will double, the acceleration will double. If the force will halve, the acceleration will also be halved. So the Newton's second law of motion's first part states that when a net force acts on the body, it produces the acceleration in the body, and the magnitude of this acceleration is directly proportional to the net force acting on the body. The second part reveals that the acceleration produced by the force acting on the body is inversely proportional to the mass. Mean, if we increase the mass of the body keeping the force constant, the acceleration will decrease, and if we decrease the mass keeping the force constant, the acceleration will increase. Simple thing, whenever the mass will increase, the acceleration will decrease, and when the mass will decrease, the acceleration will increase. These two things are opposite to each other and are inversely related to each other. So we have learned so far that whenever a net force acts on a body, it produces the acceleration in the body, and the magnitude of this acceleration is directly proportional to the net force and inversely proportional to the mass of the body. The next, there is a derivation of the Newton's second law of motion, and this derivation have a wider use in the physics. So to obtain that derivation, we first of all combine these two equations, and we get a new equation which also says the same thing which that they two are saying, that the acceleration is directly proportional to force and inversely proportional to the mass. So whenever we have to remove the sign of proportionality, we have to put in some adequate constant, some suitable constant to remove the sign of that proportionality, and to put the sign of equality in its place. So in the Newton's second law of motion, this constant is known as constant of proportionality, and it is denoted by small k. So we obtain that the acceleration is equal to the constant multiplied by force and divided by the mass of the body. Okay, what is the derivation of the Newton's second law of motion so far, which it is that the acceleration produced by the body in the body is directly proportional to the product of constant and force acting on the body and divided by the mass of the body. And next, the value of the k in this, the value of the k as a constant is 1. The value of the k as a constant in the Newton's second law of motion is 1. Okay, and when we put that value of the k, we get a new equation which is that the acceleration is directly proportional to the force is directly proportional to force is equal to the force and divided by mass. Acceleration is equal to F power m. The acceleration is directly acceleration is equal to F power m. So this equation is widely used in the physics, and another form of this equation is that the F is equal to ma. The F is equal to ma means that the force which is acting on a body can be determined by multiplying the mass of the body and the acceleration of the body. Means whenever we have to find the magnitude of the force acting on any body, we simply multiplies the mass of the body to the acceleration produced in the body due to that force, and as a result of that we will find that magnitude of that force. So the SI unit of force is Newton. The SI unit of force is Newton, and the 1 Newton is equal to kilogram meter per second scale. How did we find that unit? This unit is simply found by using the units of mass and acceleration. As the force is equal to mass and acceleration, as the force is equal to the product of mass and acceleration, the SI unit of force will also be equal to the product of the SI unit of mass and SI unit of the acceleration. As we know that the SI unit of the mass is kilogram and the SI unit of acceleration is meter per second square. So the SI unit of the Newton becomes Newton is equal SI unit of the force Newton becomes as kilogram meter per second square, and it is named because it is named Newton because of the Isaac Newton, which have discovered this Newton's second law of motion. So I hope that you have learnt everything about the Newton's second law of motion, but if you remain still confused about your concept about the Newton's second law of motion, you can ask me any question about the Newton's second law of motion in your comments, and I will surely try to answer them and will try to make you satisfied about the Newton's second law of motion. So please, if you like my video and if you have come to know about the Newton's second law of motion, please like my video, comment on my video, and also share my video, and please subscribe my channel if you have not subscribed my channel yet. So from now up to the next video.